In previous videos, we worked with Stable Diffusion 1.5 from Stability AI. It's a very basic model with limited capabilities, mainly suitable for quick tests and learning. Later versions, SD 2.0 and 2.1, never gained widespread adoption. However, in June 2023, Stability AI introduced SDXL as a preview release. Version 1.0 followed in July, and that's the model we'll be covering in this episode. SDXL delivers significantly better image quality and, more importantly, has a native resolution of 1024 x 1024 pixels, 4 times as many pixels as SD 1.5. This higher quality comes with increased hardware requirements. The required models take up about 13 GB in total, so for the best performance, you'll want a graphics card with 16 GB of VRAM. The reason is that SDXL actually consists of two models: a base model, which generates an image from text, and an image-to-image refiner model, which improves the quality of the base model's output by adding more detail and increasing realism. SDXL 1.0 is worth exploring for its dual-mode architecture alone. Let's start by downloading the required models. Go to the official Stability AI page on Huggingface. Open the image section. There you will find the SDXL Base 1.0 and SDXL Refiner 1.0 models. On the model page, you can see that the generation process is split into two stages using the base and refiner models, along with examples of high-quality generated images. Open the Files tab, download the base model and place it in the Models Checkpoints folder inside your ComfyUI installation. Then download the refiner model and place it in the same checkpoints folder. Now launch ComfyUI and load the SDXL simple template. At first glance, the workflow looks more complicated, but most of the nodes should already be familiar, and the template includes plenty of helpful comments. The first difference is that common parameters have been extracted into separate nodes, so they can be shared between both models. In the nodes library, you will find primitives. Here we are using the multi-line string primitive, which is connected to the prompts for both the base and refiner models. Similarly, we can use an integer primitive to provide the step count for both samplers. Passing parameters from external nodes is useful beyond this example. You can also generate parameters values dynamically, for example, generating prompts externally through an LLM or an API. Let's return to the workflow. On the left, we have the primitive text fields, where we enter the positive prompt, describing what we want in the image to contain, and the negative prompt, describing what we want to exclude. These connect to the clip text encode nodes for both the base and refiner models. We need two positive and two negative clip text encode nodes because each one must be connected to its corresponding model via the yellow clip connection. In the load checkpoint nodes, you should now see the base and refiner models that we downloaded. The empty latent image node defines the output resolution. 1024 x 1024 is the native size. But SDXL is also designed to generate high-quality images at the other resolution shown below, covering a range of aspect ratios. As you can see, this is a major improvement over SD 1.5, which was essentially limited to 512 x 512 images. Next we have the advanced K-sampler node. The main difference compared to the standard K-sampler is the option to choose whether sampling should begin from random noise. For the base model, we start with noise. For the refiner model, we don't. The base model outputs a latent image that still contains some noise. The number of sampling steps for both models is controlled by a shared integer primitive. Changing this single value automatically updates the steps parameter in both samplers. The split between base and refiner is controlled by start at step and end at step parameters. In this workflow, The first 20 steps are performed by the base model, while the remaining 5 are handled by the refiner. The value 20 is passed to the end add step input of the base sampler, and the start add step input of the refiner sampler. Notice that we connect the latent output of the base sampler directly to the latent input of the refiner sampler. This keeps the entire process in the latent space, converting back to pixel space only when saving the final image. Let's generate a few images of a sports car. To better illustrate the difference between the two models, let's also display the output produced directly by the base model. SDXL 1.0 produces much higher quality images than SD 1.5, and its license allows for commercial use. It's no longer considered a state-of-the-art model by today's standards, and relying on a separate refiner model makes the workflow less convenient. However, it's still an important model to understand. Shortly after the release of SDXL 1.0, several models based on it appeared that achieved excellent image quality without requiring a separate refiner, such as Juggernaut XL, but we'll cover those in another episode. If you enjoyed this content, please subscribe and I'll see you in the next video.